Good morning, my YouTube viewers. Crystal here. I wanted to make you another video on linear regression. This is a video on multivariable linear regression. And what this is this is a hypothetical Kaggle submission. I'm using the same file of 1,000 companies that I used for my multivariable linear regression yesterday. But what I'm doing is I'm going to prepare that file in a suitable format so that it can be accepted by Kaggle as a competition submission. And so this is a hypothetical example because I've not entered any competitions with Kaggle that involve this file of 1,000 companies. So the first thing I've done is to go through this program that I've written. The first thing I've done is I've inputted all of the modules that I'm going to need plus some. I just do this as a matter of course because you never know which modules you're going to need. So I've inputted all those modules, and then you've got an output that tells you the version of the modules. The next thing I've done is I've inputted some more modules, and you never know which ones that you're going to need, but the main module that you're going to need is this module here that says linear regression. And most of the modules you're not going to need because they're going to involve different types of regression and different types of analysis. But I just do that as a matter of course because you never know which ones you're going to need in your analysis. Now what I've done is I loaded up my data set and read it. So this data set I got from someone else, and it's on GitHub. So you can load up this data set and follow along with me if you so desire. I wanted to see what the data set looked like, so I just entered the command companies, and this command tells you what the data set looks like. So you've got 5 columns in 1,000 rows. The 5 columns are R&D spend, administration, marketing spend, state, and profit. And then it's got 1,000 rows and your index column, which isn't included. I wanted to get some information about the company, so I did command companies.info, and what this does is this tells you basically what the CSV file is like. Again, it shows you it's got 5 columns and 1,000 rows, and as you can see, the first column is column 0 because Python uses 0 as the first number. So even though it says column number 4, it's actually the 5th column. I now made a pivot table, and this is just so you can see the different allocation of states that this CSV file covers. So it covers the 3 states of California, Florida, and New York, and you can see that California has the highest profit. Next thing I've done is I plotted a chart so you can see where the profit in this file lies. Profit lies anywhere from 50,000 to 200,000 basically. And so it's going to be dollars because it's in America, so America works on dollars. I did a plot on R&D spend compared to profit, and this is your plot that was printed through the computer program, and it shows you that the R&D spend follows pretty much a straight line with profit except for these 3 outliers here. So if you wanted to do a single variate regression, then R&D spend would be the best one to use because it's the one that falls in line most appropriately with profit. The next thing I did was I checked administration and compared that with profit, and you'll see that the administration is clumped in a tiny little area here, except you've got a few outliers right here. The next thing I did was I did marketing spend, and and compared that with profit. And you can see marketing spend follows a straight line, basically, but not as good as R&D spend. And it's got these 3 little outliers right here. What I did was I made you a heat map, and so this heat map takes your 3 input variables, R&D spend, administration, and marketing, and it gives you your output variable of profit, and you can see what this looks like on a heat map. Now what I've done is I've defined my X and Y variables. Your X is R&D spend, administration, and marketing spend, so that's your input. And your Y is your profit, which is your output. I wanted to see what X looks like, and you'll see that X has 3 columns and 1,000 rows, plus it's got your index column that isn't included. I wanted to see the shape of X, so I did X.shape, and that shows you it's an array of 3 columns and 1,000 rows. I did the same thing with Y that I did with X. I wanted to see what Y looks like. You see it's an array with 1 column, and it has an index column which isn't included, so, and it's got 1,000 rows on it. I wanted to see the shape of Y, and you can see that it's a one-dimensional array of 1,000 rows and 1 column, because your index column isn't included. Now what I've done is these 3 formulas here are your actual linear regression, which does the bulk of the work. And so linear regressor equals linear regression. So what you're doing is you're creating an object. Linear regressor.fit into X and Y is the formula that performs the actual linear regression. YPred equals linear regressor.predict X, and that is what makes your predictions. I wanted to see what YPred looks like, and so I typed in YPred, and this gives you the 1,000 output variables. So I wanted to see what the score was, what the accuracy for this linear regression was. So I typed in the command linear regressor.score X and Y. That'll give you an accuracy of approximately 95%, which is a higher accuracy than if you had performed a single variate linear regression. Next, I printed out the intercept point and the coefficients. And what I wanted to do is I wanted to take this YPred and I wanted to convert it to a data frame. So DF equals PD data frame and profit YPred. And what I've done is I've assigned a label to that column and called it profit. So you can see this is your data frame. So it's got 1 column and it's got an index column which isn't included. But what Kaggle wants is Kaggle wants you to have a data frame with 2 columns. So what I had to do was I had to create an extra column and called that the index column. So I performed the command df.reset_index over in-place equals true. And I wanted to see what that data frame looks like. So I did a df command, and you can see that this array now has 2 columns. It has a profit column and an index column, plus a 3rd index column here, which isn't included. So in order to further prepare the outcome, I used the command final result equals pd.dataframe equals id df index, comma, profit, df profit. And what that does is that changed the name of index to ID, which is what Kaggle would want. Kaggle would want to have a label on that. So your final result, I wanted to see the final result. So again, you got a data frame with 2 columns and an index column here that isn't included. So you've got your first column says IED and your second column says profit, and it's 1,000 rows. So now what we want to do is we want to convert our data frame to a CSV file. So you've got final result to CSV, and we're calling the file submission, index equals false. And then you want to print a little message to say your submission was successfully saved. So that just prints a little message to tell you that your file has been saved successfully. And what I wanted to do is I wanted to upload the submission. So submission equals pd.read.csv, submission CSV, and I want to see what it looks like. So again, we go submission, and you've got two columns. You've got an ID column and a profit column with a third index column, which isn't included. So this is the column, this is the output that you would submit to Kaggle if it was a competition. So that concludes it for this presentation. And this is just a hypothetical example of what Kaggle would want if this was an actual competition and you performed a multi-linear, multivariate analysis of this file called 1,000 Companies and submitted it to Kaggle. And this does work. You can see it does work because I performed the regression on Google Colab, and so it does work. And the one thing that I found as going through tutorials and trying to learn data science is so many times I put the data into Google Colab and the file doesn't work, which is pretty exasperating, because if you're new and trying to learn data science, then you need to be learning with accurate coding, and the coding that they're putting in the tutorials and the news articles quite often is not accurate. And so I have a tendency to spend more time troubleshooting the code than I do actually coding, which it teaches me how to troubleshoot. And so I do actually learn a little bit about data science while I'm troubleshooting, but it's just a reflection on these people who are making these news articles and making these tutorials, because they're not checking to make sure that the coding actually works on Google Colab or Jupyter Notebooks before they publish it. But you can see that this code that I've done works, because you can see I've done it on Google Colab and I'm following it on Google Colab with you, so you can use it, and you can use this program as a basis for any multivariable linear regression that you want to do. But one thing that I will say is this file didn't have any null characters. If it did have null characters, then what you would have to do is you would have to replace all of those null characters with another variable, which we didn't have to do in this exercise because it was a clean file, and the file itself didn't have to be prepared to be used. It had all the correct data in it already. So I'm going to conclude this presentation for now. If you liked my presentation, please like, subscribe, and share. If you like the work that I'm doing, I've got my email address down below with my email address. If you wanted to make a donation to my PayPal account, it will be very appreciatively received to help me offset some of my many living expenses. And thank you so much for watching this video, and I look forward to you watching the next one.